Hello, everybody. We are going to start in just a few moments, so allow everybody to join in. See you in a couple of moments. Thanks. Hello, everybody. Good morning, good afternoon, good evening to all CAM enthusiasts. This is Daniel speaking, and welcome to another webinar about ToolKit. And this one is, as you probably saw, with enhancements in ToolKit enriched with the fixture database. And you probably note that we made a pretty similar webinar also in the past, back I think like 4 months ago, and it was very positive feedback about this feature. And we decided to make a part 2. The reason why is, yeah, by the way, I see already this webinar has been recorded as any other before. And we are going to put the link below, as this video will be also on YouTube. You'll be able to watch it. And also to see the previous one, as I recommend this, the previous one, it's the part 1. And this is basically going to be part 2, where we are going to answer on many questions that you had. And it came to our support channel as a frequently asked question. So what are those things? So the first thing will be about what we add in SolidCAM2023 SP2 release. We have the fixture database. There was very frequently and common question, can we pre-select specific fixture and link it to a machine? So every time when you start a specific part, you already have pre-selected a fixture. How to define associative fixture for multiple setups when you have 2 or 3 setups. In specific cases, we get a feedback that auto close function was not working. So let's figure it out what was the reason for it and how to avoid these situations. We have orientation and position, how to use it for pattern component and why it doesn't work in cases. How to use the jaws only for the machines that have predefined spindle chucks. Many times, in the past previous versions, in the time when we didn't have a toolkit and the fixtures inside them, it was pretty common that the particular customer, as you may know, already have embedded the chuck spindle into a machine, as this is something that you always use. And now you want just to modify to add the jaws inside of it. So you don't want to insert complete chuck. So how to manage this? Then will be a feature that we didn't pass through. It was the access control, and we didn't pass it in the previous webinar. So and we are going to show the example how you can use it in fixtures. How to make chuck assembly with a different jaws models. Very interesting topic. We now have a ToolKit Fixtures library, and it is online to download it. There were questions like why my TKZ library can't be open, when to use associative, and when to use the SL stored fixtures in ToolKit. And last, some examples that we have for using these fixtures library, also storing the tailstock, extension collets, and etc. With that being said, let's jump into some practical example, and let's start with showing the database itself. I'm using the SP2 version over here, Hotfix 2, And when you jump into a toolkit, this, by the way, this is completely empty project. I'm just having the milling part using an Haswim C1000 SS. Here it is. And when you click over here in this fixture library, in the fixture library, you have the Volt, and you're going to find here the fixture components library. So when you jump inside, these guys are something that you can use on a daily basis. For every demonstration, for every usage of any project, there you go. These are all the components, but also you can use assembly. So over here, I'm going to click on the assembly, and this library over here is going to come with installation. There are different components, and mainly we provide different Vises, different models, and you also have different jaw settings. There's also a couple of chuck jaws from different manufacturers, and also some Collets as well. Right, so this is coming with the installation of SolidCAM 2023 SP2 release. Now the next thing is how we can predefine some of the fixtures that would be available in our setup. So as you probably know, in earlier versions of SolidCAM, when you open your VMID, you can go to the working style, and this time our library, it's located in Toolkit, and here you have machine tool setup library name. Mainly this was before used only for the tools, holders, and etc. But today you can also use it for the fixtures. And I'm going to show you, let me move this one over here. Right, so I'm going to edit this library, and I'm going to change my machine tool setup. If I do that, you will see at the bottom, I already have prepared one. You can create it at any moment you want. And here is my TLM file. I'm going to open the fixture, and you can see here that I already predefined. I can put them in the storage, and I have them at different models. Those are basically the one that comes with the installation, and they're embedded in my particular TLM file. Once this is saved and you're running the particular project, you're going to see in your setup, when I edit it, this is a default settings. But now here, you're going to have all of them here listed. I'm going to now open machine preview. There you go, here's my part. But what is allowed now, I can just select specific fixture, and I can change them extremely easily by just moving my arrow to any of these. So you can imagine, guys, you can, for each machine, predefine specific fixtures that you are mostly using. Predefine them in TLM, and you're going to see them inside the setup. Just picking it, it's ready to go. Right, so this was about the TLM, and if we can use them as pre-selected. Now somebody asks if I can really pre-select it. Now this is the feature that we are working on, that you can, anytime when you create a new setup, you are going to have the one that is pre-selected for you. This is still not available, but we are working on it. And the issue is also that what is happening when you have multiple setups? Mostly you're not going to use maybe the same fixture, maybe not same jaws positions. So, but we are going to allow it soon. All right, so now how to use associative fixture. You already seen nice advantages. So what are, what everybody was confused, what is associative fixture? This is the fixture when you define all the things in your CAD environment. So you define all the fixtures inside your design, inside your assembly. And over here, I already have in my design model, I prepared for the setup 1 and also for the setup 2. Let me also change how we see this component. Right, so it's simple. Let me see why I can't. Let me try it again. Component displays this. I think I need to do it in the following way. I'm going to change it exactly and just repeat it. There you go. So two fixtures, they're more or less the same, but you can see the difference. Let me actually just hide this one before I explain it. So here I have the setup one. I don't see the, you don't see a stock. So let me just unhide my stock. There you go. So this is prepared, and most of you are going to have prepared get file inside assembly, and you can continue using this. And this is something we call the associative fixture. You're going to prepare in every orientation, like this is I have for the setup one. And over here, I have also some geometry that I'm going to do in setup two. Even though that this is the 5-axis machine, I'm going to show you how to do it with setup two. I already prepared two Macs, obviously. So the Mac 1 also for the Mac 2. And let's see how to make this. I'm going to open my setup. I'm going to rename this. So this is my first setup. And I'll make sure that my Mac 1 is selected. I'll go here. I have in the drop down menu, I have pick from CAD. And this is all what you need guys to do. Now I'm going to just run the CAD selection as I have already prepared. I'm going to select my first setup over here, and then everything gets prepared. I'm going to resume it. As you can see, this model itself, it's pretty detailed. There are a lot of details. I didn't turn them off. I just left them there. So you can feel free, to play also with the tolerances if you want to have your fixture to be done faster. And now the facing it's in progress, which means that all these data is going to be transferred into your STL and connected to your 3D model. There you go. You can see your model. And I have made one mistake here. I'm going to repeat the process. So you have here, import from CAD. And I forgot to put the fixture mounting coordinate system. This is not necessary, guys. I could still leave it, but I want to see the setup already offsetted and placed on the table. So I'm going to select and create a coordinate system. I'm going to use my bottom center of model box. I think this will be fine. There we go. The only thing that I will make sure is that my x-axis orientations are the same. So just rotate it around the z-axis. There we go. Now it's correct. I'm going to accept it. And I will rename this. You can put any name you want and accept it. Now you can see when I open my machine preview inside the setup, you can see exactly orientation. Oh, I didn't. Oh, let me just do it again. I saw this one. So let me just repeat it again. So pick from CAD. Let's do it again. So setup one, and let's do it again. So fixture, right. There we go. And just rotate around Z, accept. I'll call it OP, the second try. And over here, you have also the part mounting. Please note that this is also associative. You cannot change it. And I over here have already the distance from the coordinate system towards my Mac. I already see the question here coming. Can we use this and store it for another part? Let me just accept it and show you what is here. Something is still off. Let me just accept this, guys. Maybe it will be okay. Oh, I know what was wrong all the time. I forgot to put these values at the 0. I took it from the previous as I was playing with. Okay, so it was all the time. It was all fine all the time. All right, so as you can see, this is now associative completely. And in this case, this as associative and stored in your particular CAM part, it is completely useless in your other projects. Why I'm saying this because your specific jaws are for this part only. If you have a part that is different dimension, you're not allowed to change any jaw positions. So you will need to rearrange it inside the CAD model and then recreate it again. So associative fixtures are explicitly only for particular CAM part and then not for the library that can be shared within the two projects. It's only for this part there. So I'm going to now save and exit, and let's create another a setup. And I'm going to hide my setup 1, and over here I have the setup 2. And there you go. I don't have, please pay attention that I don't have the jaws that are on the top. And let's see how to do this. I'm going to open my right click on the operations tree, machine setup, and I'll just place it at the end of the tree. And this is going to be called OP20 or 2. And again, I'm going to pick from CAD. Obviously, this time is different CAD, but what is a mistake? I'm still having the active of Mac 1 position 1. And this is where the most of users make a mistake, because now the new assembly is going to be based on this coordinate system there. So what I'm going to do, I'm not going to make any changes, but before, change Mac 1 to Mac 2. Now when I have active Mac, I can go back and repeat the process. And to do it very quickly, just get selection. There you go. Point 2 here. And I'm also going to define the coordinate system of my fixture itself. Perfect. Just again, I need to rotate it, get that aligned, accept it. Paste it. And I can just rename this for a better recognition. Guys, everything what you rename here, it's going to be listed inside your setup. Perfect. I'm going to accept this and open machine preview. There you go. So you have now 2. You can create more setups. It's really up to you. And to ensure that this is a correct setup, you can also hide this and use this checkbox. I'm going to show you how to use that later. And I really like this feature and what it really means associative. So let me just open this and I will just change, it's this. Let me just try to find it. I think it's this one over here. I'm going to change my, this is now my symmetric, where it is. I think maybe symmetric, maybe not this one. Here we go. I think it's this one over here. So I'm going to change, to some silly value here. Just update the jaw position. There we go. So now I have a different CAD model, right? Nothing is changed yet, as this is my second setup. Nothing will be changed. It's still, I'm using the previous definition, right? But I can now do a right click and check. As you can see, we marked the setup that requires to be synchronized. I can now do right click and synchronize this, or I better want to show you another feature. You can open this and see the changes lively. Come on over here. There we go. So here, this is my previous fixture. Let's say it like this. So I can now just check the synchronization and just synchronize. So SolidCAM is automatically picking everything behind, everything is parametric and associative, yes. So just reselection will be done, and there you go. New associative position. Perfect. Right, so just for fun, let's take this example. I'm not going to hide all of these. So just for audience, somebody asked how you can change the jaw positions. So before changing jaw positions, you need to make sure that your assembly is, not rigid, and you have this icon over here. It changed the icon of assembly. So this is an assembly, but this icon, it's when it's what's it called? Flexible, exactly. So you need to make them flexible. So let me just hide this. Perfect. So let's take an example of why I would like to use for this particular fixture. I would like to use and define it in my toolkit. So I have prepared for that case the same Vise, but this is a little bit on another level. As you can see, this fixture itself has kind of two level of jaws. It's this one over here that also can move, but also the top one can move either. So both of these are kind of a linear, having linear motions, and the final clamping, is dependent of each other, right? So let's take this webinar, an opportunity to define this. And I'm in parallel, I'm going to answer on the questions like why my auto close function doesn't work inside my setup. So guys, regardless if auto close doesn't work, you can always manually clamp it. There are a couple of tools that I will like to show you. You don't necessarily need to follow the rules that I'm going to show you, but in the case you want to use the auto close, then in that case you need to follow particular rules. In every of the Vises, you can use these rules. You're not making any extensions to a definition or anything. It's not complicated at all. The only thing is that whenever you're making the jaws that you want to use as at the auto close, it must be done in the XZ plane. That's a current limitation in SolidCAM 2023. And I already predefined the coordinate systems. And as you can see, it's nothing so specific. The very first coordinate system of my base is going to be here, and it's in X is in this direction. It doesn't have to be, it can be in any direction. The first of the base is not relevant. But for my jaws, as you can see, there is a particular orientation and the rule that you need to follow. Always look at it like it's a chuck jaw, right? So if I rotate it like so, you're going to understand what I'm talking about. So follow the rule of the Z and X. So it's like it goes in this direction, right? So in that case, this is going to be my X, and in this case, it will be my Z axis. Particularly, I just put these coordinate systems here. Somebody can say why you placed it there. It's irrelevant where I place it, but I put it just on this surface over here, just for an export option. I already exported these data and in this matter. So I have exported first this base, then I exported this one over here, and then I exported as last this jaw over here. I didn't export both because this is moving symmetrically, and I'm going to show you how you can do this. So with that being said, let's define it. I'm going to create my new tool components library. I'm going immediately to save it. This is part 2 webinar. I'm going to call it just webinar 2 and just save it. I have a fixture folder. I'll just define my fixture. Actually, I don't need to define it like this. You can just do right click, add a complete, import the whole structure. And I have here in this path defined my Vise, and I will actually, let me go there again, Vise, and just select it. There we go. Inside I have the body. There you go. Pay attention that I already that I also have these the thread it's on them. That this definitely affects to size of the fixture, and I'm going to show it here. So I'm going to open the Vise, And here, guys, you can see that those two are basically minor in comparing to a body itself, which is almost 2 MB. And I would really consider, if you are going to have a huge databases, doing some optimization, like you don't need really to see the thread. I would definitely remove that or suppress the feature, up to you. Just simple extrude works also for you. To optimize the database, if you're going to have a lot of these fixtures, it is reasonable to think about optimization of these bodies. Okay, with this being said, let's define some assembly. So this is completely okay. I'm going to save it. And let's start using it in our project. Do I need to, oh, I forgot to put the joints. Let's do that again. I have my webinar too, and I have my body. Okay, so what I'm missing? I'm missing to define some joints. And here's my X orientation, and my first joint is going to be on this face. Guys, this is a new feature in SP2. I really like it. So finally, we got some, I would say, interactive fields for the joints. And let me show how easy it is. So I'm going to say this is my, I would say, joint lower one. It's lower one and then maybe upper. We're going to see how to call it. And it's my linear. Okay, so it's my linear. And where it's located? It's located on the top. So you were always able to put the values like so. If you know the values, or you could always calculate it based on the selected coordinate systems. But there are better options now. You can click on this field over here, and you can just pick on the model. There we go. And so I can automatically calculate what is the value. So let me just repeat this again. So you just click on the field, and it doesn't have to be the surface. You can even click on any edge. So I'm going to click on the edge, and we just move it along the z-axis. There we go. Almost it's same it works for the rotations. You can only use it once. So for instance, I would like to rotate my x-axis towards this over here. Of course, I could do it by rotating around the z, sure. But for me, it's easier just to pick on my x-axis and just click on the surface. There you go. Rotation is automatically applied. If you want to reverse it, you can again click on this and again repeat it. It will reverse the orientation. You cannot do it like multiple times, so he's not doing according to your previous local coordinate system, but you can only apply it once. I think it's quite good and quite enough. So I have here my joint. The only thing that I need to fill in is my axis data, so I'm going to call lower joint. And I'm going to leave the axis. It's along my x. I'm going to apply it, and that's all. Let's say that Joe's over here. I call it Joe's bottom here. The same I need to apply. Similarly, I need to apply it over here. I'm going to set my as linear. This will be my, I call this Joe's top. Let's use it like this. It's also along the x. I just accept it. And I need to shift it. So along the z, I need to shift it according to this edge. There you go. I forgot one thing, guys. I said at the early beginning that this is, so all the geometries that you can see here are also like they're symmetric, so they're mirrored. So for this particular joint, I'm going to use a pattern. I'm going to have another item just added 180 degrees. You can see the results. You can see two axes over here, and just click OK. Right, now let's use it in SolidCAM. I have here my first setup, and let's try to use it. Click on None, and let's start from beginning. I have my table station. I open my Vise. I'm going to put the body, Joe's bottom, Joe's top. I hope I didn't forget something. There we go. Voila, it's perfect. I can also move my axis that I created, and I have it over here. So all that I defined is my lower joint, and it also moved the upper joint. Now, what are those values? Of course, they are the axis values that we define, but they're very important if you want to use a close on stock, automatic close on stock, or auto close, however you want to call it. Anytime when you want to use it, you need to make sure that there's enough space for the closing. If you place your jaws inside the model, it's not going to close it. So they must be outside of the model, so the clamping gets performed. I think this is enough for now here. I still can't use this this assembly, because if I try to use it, he will say, hey, there is no part mounting point defined. And I'm going to use it on my body here. I just right click, add part mounting. And again, these coordinate systems here, guys, it can also be used to shift my coordinate systems. I can pick on this, pick on that, surface or point, and there you go, ready to be used. Reused anytime you want. Open machine preview, let's set up these things here. Just pay attention that if you have any values here to place it on 0, there you go. I'm going to rotate it around the X. I can also use my orientation and position, very nice feature. There you go. And just for this, let me just turn off the machine. I'm going to click on this face, just click on this face, just made it. Why am I don't see my clampings? Did I? Oh, one very important thing I forgot to do. It's fine, because I want to show you that nobody is perfect, but there is some mistake that I made. There are, when I go to tool components, I forgot to set that those components are jaws and not body. So jaws top and bottom, you can change it to be jaws, convert to jaws. They're prismatic jaw, just have an exit. Let me open my toolkit. I think I need to, if I'm using it here, right, I'm going to save it and just where it is. Here we go. I'm going to just reload the component, each one of these. Break. Interesting, why I don't. Let me. Why it doesn't want to reload? Okay, I don't know why, to be honest. It should. Maybe I need to. They are okay. So let's repeat. Okay. Let me just verify that's okay. Yeah, fine. Again, just put some values. This will be okay. And of course, move it to your table station before you use it. And there you go. Oh, I almost forgot that one. Okay, so here it is. It's in place, and now you can have your closing. There you go. So the advantage between the associative and the STL, the one that we just predefined inside the toolkit, it's obvious. Now this assembly, I can just reuse it in any of my project. I can also see it over here as selected. There you go. And there was one question like, why we are not able to see the picture in the CAD environment? We are working on this feature, just a small sneak peek. You are going to be able to see this view in any moment, and also click on the fixture. Just stay tuned. For now, this is on the job level. I forgot to mention that this will be available on the job level. For now, it is just like here, like so, in the preview. Right. Let me see questions there. Okay, nice questions. So I will answer actually at the end of this webinar. What is the time? Okay, perfect. So next, oh yeah, something that I forgot to mention. Let's take an example, guys, that I haven't defined this fixture properly, like in XZ plane for the jaws, and I have used some other values, and I'm not able to use this auto close, right? So in that occasions, if you have those kind of occasions that auto close is not working properly for your particular example, you can always use this set position. Let me just turn off this table show and hide. So you can always use the set position. Now, what is important when you're using the set position? You can note here when the orientation and position dialog is popped up, you will note that the one on the right is highlighted, while the one on the left is not highlighted. Basically, orientation and position will accept motions only if you select the one that is highlighted. And this is important to mention. So now I can just use these, just clamp, take this, take that, and just mate. There you go. If you try to do that with the other one, it will be completely ignored. I think this is very nice. Come very oftenly this question in support channel. Let's go further. Yeah, this is all that I wanted to show you. Bye guys. No, let's go. Let's jump into Milter now. Okay. Very often come question in the support channel, as I mentioned earlier, like I want to use jaws only on the machine, and how to use that. It's let's see this. Perfect. You probably saw this part also in the previous webinar. And inside my setup, let's see what I'm not using anything. This particular machine already, it doesn't have any jaws, so it doesn't have any chuck. But you can imagine that we do have physical chuck, and we want only to insert jaws. So how to do that? In previous webinar, I showed the example when I jump into ToolKit from here. I'm still going to do that, but also stay tuned. And what's the way? The way is there's a multiple. You can predefine the chuck in a head with specific jaw and use it. Or you can just take this chuck template that you can see over here and just drag and drop. Now what you can see is that this is complete assembly with my chuck itself and also the jaws. In order to not see this or not to take into account, you can basically hide it. Now, many of you can say, why I need to have this chuck? Basically, the chuck is there because it has the property of how many jaws you can have, what is the direction of movements, and all the axis information is stored in this chuck. So you cannot really remove it. But what you can say graphically is that this is a 3D model without no 3D model selected. So I can go here, select the 3D model, and now you only have your particular jaw. So you're just changing the chuck, the jaws itself, all diameter and stuff as so. If you want to move the position, this is also commonly asked. You can go to your chuck, doesn't have any geometry, and change your joint. So I can put it here to 0, then it will be there. So let's see how that looks. I'm going to accept it, and now you can see only jaws are here. I can of course offset it together with a part, and that's basically the way how you can just take the jaws. You can predefine this structure for any further usage and just modify jaws geometry itself. Now the next topic is about axis control. Axis control, why we are using it, and some example that we can put out in this webinar. And definitely there are many examples. Okay, and I'm going to show you in this one. Let me just open this. Let's go to the next slide. So this is one of the examples when you would like to use your axis control. Now, the chuck itself, it has capability to move all these three joints. So you can imagine that this has the axis here, axis there, and also axis there. And all of these three joints now have capability to have a different geometry. So you can see this is completely different jaw for each of the joints. Now, what will happen in ToolKit? In ToolKit, you are going to see these three axes completely separated, and they're not connected. So you can move the X1, and X2 and X3 will not move. So this is where the axis control comes across, where you can unite all those three joints into one axis. So this is the first usage of axis control, and the second one, I'll call it specific one. I quote it, you didn't saw it, is that you can define a chuck axis through the axis control. So what is the chuck axis? The chuck axis is the specific virtual axis, we call it, that takes into account the reference point on the jaw to calculate, clamping diameter. So let's take a look how you can use both of these and define it inside SolidCAM. And for this example, I'm going to open the same assembly that I used before. And it is this one. So nothing specific, right? So I have created here the, I don't know why I created here actually. Maybe it's a mistake, but it's okay. But the most important is the one over here that I have my jaw coordinate system. Again, Z goes here and X goes there. It's not really important where it is. You can place it over here, you can place it over here, but just make sure it's somewhere, in the in this section, because we are going to find, the very first reference point that will be later calculated. So I already exported these. I'm going to create and insert those into my tool component first. As I did it differently in the previous webinar, I want to show you this way as well. So open the same TLV, and I'm going just to import the structure, the same structure that we have, but this time it's the chucks. So take it, I have my chucks here, I have my jaw, but this time I'm going to convert it to jaw immediately. So and it's a chuck jaw. This is also important. Let's see, I have it over here. And what I need to do, just first, it's a linear joint. That's for sure. I can call it my, let's call it pattern axis. You're going to see I'm missing the N. There you go. So pattern axis, because if I use my jaw on my pattern axis, it's going to multiply my jaws automatically across. And I'm going to define my pattern is like this and just add. So I have 0, 120, and 240 over here, but I'm going to shift it. I'm going to take it from this position. Again, I'm going to use this feature. Just click there, click on the surface, and it's shifted. Perfect. Now, if I try to use this on my joint, my jaw, you're going to see only 3 of them, but this, yeah, it's okay. So let's try to use it. It will be easier to show it than to explain it. So I'll say to none, let's do it. I have it in my library. I'm going to open my library. I have my chuck, main spindle, and my jaw. At first, you think like, Daniel, for me, everything looks okay, but look what I have here. It's my X, and I can move it around, but everybody would say, Daniel, this is not 20. The 20, it's basically a distance from this position to this position. So this is, guys, 20. Okay. What I want to do, I want to take the reference point that I have on my jaw. I need also my part mounting. My power mounting I'm going to place according to this point. And now this is my reference point, right? Here it is. Now currently it's 0. You can change it to any position you want. But as you can see, nothing is changing. So I want to take this into account. So how to do that? Let me not save it. Let's go back into my library. Go and click on Chuck. And over here, you can now define an axis control. You can define axis control only if you have axis on your joints. If you don't have it, if this is like a static one, you're not going to see axis control. So now you can do it. This is how the interface of axis control looks like. Nothing so specific. Let me just change this name. Actually, it's not important at the moment. And if my joint is linear, and if it's patterned, those are two conditions, then we have this example, or sorry, this case of chuck axis. How to define the chuck axis. So I'm going to add a virtual axis here. Just click, and you're going to pop up this message, hey, this is potentially a chuck axis. Do you want to continue? I'll just say yes. You can define here the limits. And so I'm going to click OK. Now, you can see that now previous axis disappeared. It is in my slave axis here, and it's very specific function used. You cannot modify it or anything. And I'll just click OK. Perfect. Now let's open it inside my project again and to see a difference. Again, just open it in my Vault, Chucks, take it. There you go. And I'm going to define part mounting over here. Super easy, guys. But now, if you see, I do have my slave axis, but it's locked. But now I have clamping dimension. This is, guys, really a 0. I can put my minimum and maximum, of course, but now this is the diameter. So this is the first usage of axis control. I can just place it to 60 like so, accept it. I have it over here. I really like this feature. I can just move along to any of these and just auto close. There you go. It's just perfect. You can also auto close to a target, and we are going to close it on target if necessary. We can also take apart and be relevant to a specific surface by clicking on this surface over here, and I want to be, for example, from face of my chuck, align it, perfect. I want to be actually, let's say differently. Usually people are on lathe machines, they're saying the stick out. So you can take the face, match it, and you say, your stick out is, like 75. Enter, and your stick out is 75. Accept it, close on stock, and there you go. It's so nice, it's so easy. But let's see another example of axis control. So I'll click on none, and this time again I'm going to not pop up, but I'm going to open the previous assembly. So edit tool components, and what if I want to have all three what is it called? All three jaws different geometries. In such a case, I'm going to create another set of axes. I'm going to create my linear axis 1. I'm going to call it jaw 1, for example. It is not patterned. Pay attention on this. I'm going to recreate. So there's no pattern at all. And I'm just going to copy, paste, paste. Now I have 3 jaws. What I have to do, I need to set orientations correctly. So my jaws 1 is okay. My second joint is 120, and my third is 240. This is not enough, as we need to fill in the axis data. So for my second jaw, I'm going to take my axis data, and I didn't click. And let's modify the the axis data names here. So this will be my Joe 1. It's according to my x-axis. Yeah, by the way, the axis vectors, when you're defining it, it's not according to your Joe, it's not according to your joint, but according to your coordinate system of your STL. Pay attention to this. So I'm going to click this OK. Then on the second Joe, I'm going to click on my Joe data. This is my Joe 2. And now this is not, this vector over here is not along my X. So I need to rotate it, but there's a vector. So how to do it? Very simple. SolidCAM automatically calculates for you. Is the very first below the current selected. Just select this one and that's okay. The same I'm going to do for the Joe 3. Joe 3. The very first one, click OK. There you go. Okay, so how to use this? Let's take the example. I'm going again to go to the setup, open the toolkit. I could save something at least to not repeat every single time. So the chuck, I take the chuck, I take my Joe, but this time is different. I don't want my Joe to be on my patterned axis. Instead, I want to be on my Joe. There you go. Now, what you can see here, guys. Anyway, I'm going to do it in the different way. So let's take some from the examples. Fixture components, chucks. Let's take some Joes from different assemblies. Maybe even take, the parametric Joe. Why not? I'm going to take this into my Joe 2, and this one also in my Joe 3. You all agree that this is this is 3 Joes, right? What I forgot to do is to connect all these 3 axes. I'm going to do that in the next step. So for now, you can see I'm going to open my quick axis, and over here there's a list. So I have my clamping dimension. If I now move it, nothing happens. I have my Joe 1. I have my Joe 2, and I have my Joe 3. I want to connect those. So I'm going to, in this example, I don't want to go inside my library, but I'm going to break the link and just connect these into my axis control. And there are 2 ways how I can connect them. I can connect them. So this Joe over here is my Joe 1. It can be a master axis to my slave axis, or I can create another virtual axis, let's call them virtual 1, that is going to have slave axis of Joe 1, 2, and 3. It's really up to you how you're going to do it. I'm going to do it differently. So my Joe is my master, and I want to say that Joe 2 and Joe 3 are the slave axis. So I have my Joe 1 as a master. You can change the connection. You can change the ratio. Very important. You can put a function if you want. I'm just going to click OK. This time, if you open your quick axis, you're going to see that Joe 1 is axis here, but others are just connected. So now you can see if I'm moving, they're all connected. Good, good. And do we have anything yet? Yes. Okay, so we come to the end of the webinar, but I want to show you a couple of more things. As I promised earlier, let me just click here and close now. And that's like Toolkit Fixture Library. There is online version now. So you can, all of the things, basically what we've shown you from some brands, we already predefined for you guys, for all SolidCAM users. You can go to SolidCAM forum.solidcam.com. And when you open it, you can use Control F to search for a toolkit. We're going to see here sections SolidCAM toolkit, the powerful tool table. You open it, and here you're going to see Fixture database by SolidCAM. Done by Yarden. Awesome job done by him. And over here you can get, for now, the 5 brands that we covered: the 5th axis, chick, skirt, length, and chunk. And there's a lot of the things inside, guys. You can just take it and just use it. In this example, I think I already download it. And if I just open a CAD here, you're going to see two files. One that has the assemblies, but another that has only the TLV. So you can open any of these, it's completely okay. And I'm going to tell you that there was a questions about why can't, take the TKZ file. It's like an unknown file name. It's pretty simple to do. You just do a right click here and you have here the open with and just choose application and try to find in your installation folder the toolkit application. So just make sure that this is there. And it's very simple, just double click and SolidCAM. I just specified the version. And what SolidCAM is doing now, he's exporting all these library into your folder. All of them will be copied. I hope he copied. Going to try it again, but maybe I do have it already. So let me just open the no, the two libraries. Yeah, there it is. Current library is there. Let me just open any part. Toolkit. Let's see a little bit of these. I can actually use it like this. Edit to components and try to find this current library. There you go, guys. So enjoy. You have everything here. You can also, if you have the assemble, so all the things that are available in the CAD, it's available here for you. So you can make also assemblies. They are very flexible. So you can make any assemblies that you want from these databases. Right, and a couple of more minutes before ending is this is this example. We do have like example when we are going to use the back spindle as our tailstock. So you can see this is an example where this is directly attached to a spindle itself. A very nice example when this is just used frequently. You don't want every time to have this model in your design CAD file, right? Just pick it and use it. And the next example here, I just placed this example for Swiss type machines for all Swiss type users there. Many times for specific applications, you need to use extension collets on the sub spindles. In that case, you can pre-create these extension collets and just use it on your sub spindle, just picking from the drop down menu. And that's it. Very simple and easy. Let me just go through before we finish the webinar. I'm going to pass through the questions. Wow, 1,000 questions. I'm just joking now. There are a couple of them. So fixtures. Let me just go quickly for. Okay, question is like, is it possible to use only one chuck with main and back spindle, no matter how the Z coordinate system is aligned on inside your post? Yes, this is possible, absolutely, but you need to create in that case kind of two assemblies where you are going to reorientate your mounting. So what I'm talking about is this. So let's take an example that I have assembly, and I'm going to take my defaults. So the question was, can I use this one for main and sub? Usually it depends on how the post-processor is defined. Let me go back here. Oh, this is my editing. So let me go inside my setup. Take the assembly and just, so the question is, can I use this one on main and sub? So I cannot now take this and kind of say, okay, I want to use it also here, but you need to physically copy it over here, like so. So that's possible, but of course, if the orientation is different, then you can't do it like that. You need to create another instance. If you want to be automatic, of course, it can't be. You can, but you need to, change the orientation over here in the mounting, so you can rotate everything around, for example, x-axis. So this depends of how you set up your machine and combination. But I believe that all machines guys can do, the z-axis here and the z-axis opposite here, just matching, no problem at all. Another question. So setting up the Vise is similar to make a tool assemblies with shanking holders. I'm not sure if it's similar. As you can see, we tried to not make any differences. The interface looks absolutely the same when you're setting and making, the things with us in the holders when you're making the tool assemblies. The only difference is that you don't have a cutting point. There are two features, either the non-cutting point. So you can do non-cutting point, as you can see here, or you can put at part mounting. So this is a main difference between Chuck, let's say Fixture, and the tools. And you can see that we have a differences in this icon. So this icon over here represent the Fixture, and if you're using the tools, in that case, let me try to leave here and open the toolkit itself. You're going to see that this item over here is using it's a tool itself, but if you go to your storage, you're going to see that this is a Fixture. I passed through the question. We'll be able to see fixtures in CAD environment, even if it's STL used. Absolutely. We're working on this feature. You will love it. It's a kind of extension of what we have now. Very good. Well, thank you very much. All right. Yeah, this is all the questions. These are all the questions. If there, guys, if there is anything specific, feel free to write us an email. We are happy to hear your opinion. So take care and see you in the next webinar.